Hi there, kids. Today we're going to be talking about graphing quadratic functions. It's also one of my faves. We've talked about some of these things before, but we're going to revisit them, and instead of just pointing out parts, you're going to be graphing them yourself. So let's recall that the quadratic form of the standard form of a quadratic equation is y. We can change that f of x to y if we really want. Y equals ax squared plus bx plus c. Standard form. We looked at this last week when we did our factoring. Shape of the quadratic graph is a parabola. We've talked about this before. It's kind of spelled parabola, but it's called parabola. Parabola is symmetric about a central line called an axis of symmetry that I abbreviate AOS that intersects the parabola at one point, the vertex. It's either the topmost or the bottommost point. The axis of symmetry is defined by x equals negative b divided by 2 times a. It's the equation we're going to use to find the axis of symmetry. The y-intercept is always at c, every time, no matter what. Okay, those things are what you're going to need to know moving forward. Example 1 here, we're skipping. Moving on to example 2, though. Find the vertex, the equation, the axis of symmetry, and the y-intercept for both of these graphs. We're going to mark them on the graph, and we're going to mark them over here on the side as well. We've done this before as well. This very bottom point here is the vertex, and it's also the very top point on the next graph. So the coordinates of the vertex on graph A are -1, 0. Left 1, up and down, none. The axis of symmetry is a dashed line that goes through the vertex that splits the parabola in half. So that is the AOS. The equation for the axis of symmetry is x equals always, and it's always the first number of the vertex, -1. We want the y-intercept. There's only one of those ever, if any. So the y-intercept in this case is 1, or you could write it as a coordinate point, 0, 1. So those are the three things you want: the vertex, the axis of symmetry, and the y-intercept. I've given you the vertex on the graph below. Now you take a moment and define these three things, write the coordinate points, and label them on the graph. Okay, so the vertex, I showed you where it was, but if we wanted to write the point down, it would be at 2, 3. The axis of symmetry splits the parabola in half and goes through the vertex. So in this case, the axis of symmetry is x equals always 2, the first number in the vertex. Finally, the y-intercept is right here. And it is at -1, or 0, -1. All right, hope those make plenty of sense to you. Now we're going to use them more here in example 3. We want to find the vertex, the equation, the axis of symmetry, and the y-intercept of each of these. We have to do them in a specific order. We always have to do the axis of symmetry first, because that will give us what we need to find the vertex. So to do the axis of symmetry, we need to use the equation x equals -b over 2 A. We talked about that above. First, what I'm going to do is list what A, B, and C are in our equation, since it's already in standard form. A is the number in front of the squared term. That's 2 in this case. B is the number in front of the linear term, which is 4. And C is the constant, -3. So to find the axis of symmetry, we use x equals, and I always put the negative out in front and then put b in parentheses, just in case your b is negative. So -4 over 2 times 2. That is -4 over 4, which is -1. So your axis of symmetry is x equals -1. Always an equation. Then we want the vertex. Well, to find the vertex, we're going to take our axis of symmetry value and plug it into the equation. And then whatever y is equal to will give us the y portion of the vertex. So we use -1, everywhere there's x in our original equation. So we simplify a bit. That's y equals 2 times +1. 4 times -1 is -4 minus 3. Well, that's 2 minus 4 minus 3, or -2 minus 3, or -5. So the y portion of the vertex is -5. The x portion is what we got for the axis of symmetry. So that, my friends, is your vertex, -1, -5. Last but not least, we want to find the y-intercept, and that is always c, so it's -3. Or if you'd like to write the coordinate point, 0, -3. Okay, that's how you're going to do it for every quadratic equation. You can use those exact same steps, process in that order every time. Part B is all you. Do it. Ready, set, go. Okay, we're going to start out by listing what A, B, and C are. A is -1. There's an imaginary 1 in front of that x. B is 6. C is 4. So first we want to find the axis of symmetry. X equals -b over 2a. For this case, it's x equals -6 over 2 times -1. That's the same as -6 over -2, which is 3. So our axis of symmetry is x equals 3. For the vertex, we're going to plug that 3 in for x in our equation. Y is -3 squared plus 6 times 3 plus 4. In this case, we put the negative on after we square. So this will be -9 plus 18 plus 4. So that's 9 plus 4, or 13. So that means our vertex is 3 that we got from the axis of symmetry, 13. Last but not least is the y-intercept. And that is C, or 4, or 0, 4, whatever you said. Okay? I hope that makes an amazing amount of sense. I'm not there to see your faces and your confusion, so let me know if you need help. Next little fact we care about, parabola opens up, or like a cup. That means A is greater than 0. So if your parabola is opening in the positive direction, A is positive. If your parabola opens down, like a rainbow or an umbrella, that means that A is less than 0. So opens up, opens down. Opens up, there's a vertex at the bottom, and that's a minimum. That means there is a place where no other points go below. If it opens downwards, that means A is negative. This one, A is greater than 0. This one, A is less than 0. There's a point that no other points will go above, and that's a maximum. Minimum is the lowest point. Maximum is the highest point. Okay? Point that doesn't go below, point that doesn't go above. Minimum, maximum. Positive A, negative A. If it opens in a positive direction, A is positive. If it opens in a negative direction, A is negative. Okay? Find a shortcut, a little thing to remember it that makes sense to you, because we're going to use this so much. So we want to see if this function has a maximum or a minimum value. Well, we're going to look at A first. A is -2. If A is negative, that means we use this second instance. A is negative. It means less than 0. That means our parabola is going to open downwards and have a vertex at the top. And it's going to have a maximum. Okay. Now we want to know what that maximum value is. Well, the maximum value or the minimum value, depending on what you have, is the vertex. So to find the vertex, we have to find the axis of symmetry. So let's list. If A is -2, B is -4, and C is 6. So the axis of symmetry is x equals -b over 2 times A. That is, in our case, -4 divided by 2 times -2. Well, -4 is +4. And 2 times -2 is -4. +4 divided by -4 is -1. So our axis of symmetry is x equals -1. We need that to then find the vertex. So we'll have y equals, then we plug in -1 for all of our x's in our original equation. Let's do a little simplifying. Y is -2 times 1. -4 times -1 is +4 plus 6. Well, that is -2 plus 4 plus 6, which is 2 plus 6, which is 8. So that means our vertex is -1 from the axis of symmetry and 8. And that is the maximum value. Next part, state the domain and range of the function. Well, the domain is always all real numbers. For every quadratic function that you graph, the domain is always all real numbers. The range has to do with this y part of the vertex. It's going to be y. And that y part of the vertex is going to go here. I'm going to leave some space because right here we're going to put something. I'm going to scroll up just for 1 second, maybe, if it lets me. There we go. We said that we were dealing with this second option, right? Where A is less than 0 because our A is -2. So A is less than 0, our parabola opens down. I mean, it's a maximum, and it's a high point. There's nothing that will go above it. So imagine this point right here is -1, +8. Are the points that are on the rest of the parabola above this point or below? They are below. Everything else is below here. So that means this value of 8 for y is as high as it's going to be. All of the rest of the values for y are less than 8. And I want you to notice that it's less than 0. So if A is less than 0, your range is less than or equal to. Okay? Just have to think about what the rest of the values of the parabola are doing. If the rest of the parabola is above your vertex, then it's it's greater than or equal to. If the rest of them are below, it's less than or equal to. This takes some practice. I'm so sad we're not together to do it. Last but not least here, I've given you a step-by-step approach to how to graph the full parabola. And we're going to do it together. Step 1, find the equation for the axis of symmetry. That's the AOS. X equals negative B over 2A. Well, let's list our A, B, and C first. A is 1. B is 4. C is 3. So axis of symmetry, X equals negative 4 over 2 times 1. That is, forgot to put that in parentheses, negative 4 over 2 or negative 2. That's our axis of symmetry. So I'm going to put a dashed line right here, X equals negative 2. It's going to split our parabola in half. Step 2, find the vertex. So to do that, we plug this negative 2 in for our X. Got negative 2 squared plus 4 times negative 2 plus 3. That is negative 2 times negative 2 is 4. 4 times negative 2 is negative 8 plus 3. And that's y equals, I forgot. So we have y equals negative 4 plus 3. That is negative 1. That means our vertex is on the axis of symmetry down 1. So right there. Then we want to know if it's a maximum or a minimum. Well, A is greater than 0. So that means our parabola is going to open in a positive direction. A is positive, parabola opens positive. So our vertex is a minimum. Find the y-intercept. That's going to be C, which is 3 in this case. 1, 2, 3. Points are coming together little by little. Use symmetry to find additional points on the graph. So if we see that our y-intercept is 1 to the right, there's one empty line, and then the y-intercept is at 3. I can go the same number of spaces to the left of the axis of symmetry and have it be in the same spot because it's symmetrical. So the axis of symmetry is going to go right in the center, and an equal distance on either side is going to be that point with the y-intercept gave us. Let's find one more point because I like to have lots of points in here. To do that, I want to find a point for right here on x equals negative 1. To find that point, I'm going to plug in negative 1 for x to our equation. Negative 1 squared plus 4x plus 3. Oh, x. I missed it. Look, dang it. X is what? Negative 1. So we've got y is 1 minus 4 plus 3. That is negative 3 plus 3, or 0. Okay, so at negative 1, y is 0. That's 1 to the right. That means 1 to the left. We've got the same spot. So these same points should all be equal distant from the axis of symmetry, and then there's just one vertex. Well, now I can connect these all with a smooth curve, which did not happen. Let's see if I can try it again. There we go. And that's our parabola. It doesn't say it on here, but we're going to do it. We're going to find the domain and the range because we can't have too much practice on that. Domain is all real numbers all the time. The range, we take this value of the vertex, this negative 1. We put a y in front of it. And we look at A. A is 1. That means A is greater than 0. All the points on our parabola are above the vertex. So that means all the rest of y is greater than or equal to -1. All right, hope this makes some sense to you. It's graphing, but it's a different kind of graphing. I'm so sorry that we're not together to learn this. We're just kind of getting a crash course in graphing parabolas. I've got some different kind of practice for you today that I hope ingrains this just a little bit. I miss you terribly. Please take care of yourselves. Bye-bye.